Welcome everyone. Greetings and welcome to today's educational program. This is Dynamic Software Test Planning. My name is Kurt Stuke and I'm with the Quality Management Division. This particular webinar is a joint offering between the QMD, or Quality Management Division, and the Quality Inspection Division. And I am joining this meeting from beautiful Kentucky, New Hampshire on the East Coast. We do have your lines are on mute. Now, I've tried to unmute them so that if you want to ask a question, you could, but what we ask is that you wait until the end of the presentation. If in the interim you have a question, you can put it in the chat room, but we'd like to get through the material. Dan, I believe it's about 35 minutes, is that correct?
Yes, thank you.
Okay,
yes.
So we'll get through the material and then we'll attend to the questions. And hopefully by that point, I can figure out how to unmute everyone so that they can actually ask. Today we have the pleasure of hearing from Dan Zrymiak. And Dan is from Surrey, British Columbia, and has more than 25 years of professional experience in quality management. He has worked in Hong Kong, Germany, and Canada with specific experience in business services, manufacturing, medical software, and web commerce solutions. Zrymiak was also a part-time faculty member at the University of British Columbia, British Columbia Institute of Technology, and Queanbeyan Polytechnic University, teaching software quality assurance, software testing, statistics, and configuration management. He has attained distinctions as a quality professional, including designation as an ASQ Fellow and receipt of ASQ's Crosby and Feigenbaum medals. He is an ASQ Certified Six Sigma Black Belt, Manager of Quality and Organizational Excellence, Software Quality Engineer, and has multiple lead auditor credentials. He has been a conference speaker at multiple international quality conferences. Zrymiak is an ASQ Quality Press author and reviewer and serves on several ASQ divisions and technical communities in multiple voluntary member leader roles and committees. So without further ado, Dan, if you could, take it away.
Yeah, did you want to first do a bit of a expression about quality management and inspection divisions?
Well, I did put one line in there. This, again, is a joint offering between the Quality Management Division and also the Quality Inspection Division. And if you're interested in getting involved in either of those two divisions, the newly revamped ASQ, My ASQ site is chock full of ways to take on a more individual role. But again, this is being offered by two groups actually collaborating and working together, and that is the QMD group and the Quality Inspection Division.
Thank you. Thank you, Kurt. It's good afternoon, everyone. It's my pleasure to present to both ASQ Quality Management and the Inspection Division. And as mentioned, I was recently at the World Conference when all the divisions were available and giving their best impression. So this is something that I encourage everyone to join and become more intensively involved. It's very satisfying. And for $10 for a division membership, it's well worth, you get returns many times over. As far as this particular presentation, this is the same one that I did in Seattle about 2 weeks ago. It's Dynamic Software Test Planning. And this, to summarize, it expresses how lean can be applied within a test project, a software test project, to use the benefits and advantages of lean to not only fulfill what it is that has to be done, but do so in a way that uses the limited resources and time more effectively. And also creates, instead of pushing the solution out, uses the demand and prioritization to drive and draw the necessary work. So it's, as I say, interdependent and concurrent backlogs, and that's what I'll elaborate on. So coming to this, what was the impetus for this particular concept? And this happened to me in real life, where I was in a situation we had very demanding project, very highly visible. It was federal government involved, so there wasn't a whole lot of flexibility in terms of the level of rigor and risk management that we had to demonstrate. It also had to require a certain level of security clearance. So as you can appreciate, there was a lot of watchful eyes on this. We had fixed release dates, but going into the project, there was flexibility and fluidity of additional requirements, additional expectations. So that was a lot to manage, and this is a way of how we were able to meet that challenge, particularly with respect to getting redesigns and extended requirements after the fact and having to deliver on those. We had to manage this with workforces located in different parts, particularly some that had different capabilities and different security levels. So all those assignments had to be managed strategically so that the best people, the most capable people were on the most critical elements of the project. And this presentation will show how that was managed. And then really how to, we didn't have the luxury of adding more people to meet the workload, so we had to use our people very strategically, which I'll show how some of the lean techniques were applied for that challenge. These types of challenges are characteristic not just of, say, a government project or you know, anything special, but quite often the same dynamics apply. So starting from a basic cost to quality model, the idea is that if you are running short on time, you cannot compromise the verification validation. If you do that, you will pay for it at the end. The failure costs will be raised. So the first benchmark presumption is that the best solution is always to have as much verification, validation, and especially with the prevention that you're able to do as possible. So any work that's done to enhance that will pay for itself in the long run. So the second benchmark, and this is the nature of the project that we had, is the traditional software development life cycle, the waterfall. What that requires is a completion of the prior phase, that not necessarily the full completion, but at least as you can see, it tends to be about 60 to 70% before the next phase is initiated. So what that means is that if a waterfall model was strictly followed and applied, you would actually have considerable idle time. That is, you have capable people who are ready to work, but because of the protocol of the project, they're restrained from actively carrying out their tasks and responsibilities. So because of that, that pushes out the timing and duration, and especially if there are delays in the early phases like requirements and design, that slippage will propagate through to the end of the project, which if you have infinite release time is not a problem, but if you have a fixed release date and you have slippage in those early phases, then that's where it becomes necessary to have a more creative approach for testing. So, and this is just a more elaborate example of that. The third benchmark is using lean, and there are many items within lean that have been effectively applied for both manufacturing and services. Now, using these items of particularly consolidating, standardizing activities, and making sure that you understand where the wastes are, where the weighting is in a test project, and looking for ways to remove that. That is where value will be realized. So in the case of software testing, I've identified for the key waste categories, what does that mean in a typical software test project? And now, software testing is not like manufacturing. We have physical documents. A lot of it is electronically provided, so you're not having a warehouse, so to speak. You're not having forklifts and pallets, but you still have to provide those artifacts in a timely manner and making sure that they're consistent. So having those available as soon as they are ready for use, ready for application. That is critical to reducing the waiting time for having people on your team be made productive. This is especially true when you're managing people outside of your own location or time zone, because if they're idle in the middle of your night, that is even more difficult to manage. So you have to have the necessary planning to make sure that there's a sufficient backlog of work for them to do while, during your night hours, so that they can have a productive shift, and you wake up the next morning and they've carried out their capabilities. So as you can see, one example is motion. Now, in a test in a factory, you'd have, let's say it's a physical activity, and you want to make sure that the person has their steps counted or their hand motions. Testing doesn't really work in that way, but one thing that could be done is making sure that you have as close to a single point of reference as possible. When you're tracking items, say requirements on one tool, and then your different tests on multiple tools, and your defects on a third tool, it becomes an additional work effort in itself to cross-reference and make sure that all of those are coordinated so that updates are propagated to multiple tools, which itself is a wasteful activity. It would be better to have everything on a single point of reference so that one update made at one part of the project is automatically propagated. That's not exclusive to software testing. That's also a very big issue for IT service management, DevOps, and any sort of system tracking. And that's very relevant not just for product development, but also if it's internal controls, information management for things like COSO, Sarbanes-Oxley, or any other internal IT accounting system. 2 items: overproduction and overprocessing. So even though it's important to have thorough software verification, validation, software inspections, there is an economic value. Once something is discovered, for example, once you've discovered that a particular build or feature is defective, there's minimal value for reinforcing that by repeating the same set of tests. So then, as I say, new discoveries have minimal impact, but if they're still consuming time and tester activity, that's a point where you have to cut it off and shift the work to areas that have not yet been tested. Also, the overprocessing is very important to understand what quality definitions are required in the software. And software quality has many dimensions. In addition to functionality, does it work? Does it do what it's supposed to do? There's reliability, and reliability is something that's measured in terms of how extensive of a failure. Performance testing is very important because you're simulating how the system or solution would work under simulated usage levels, peak levels. But at the same time, if you're required to build something that can be used concurrently by 1,000 users and you're testing it to 100,000 users, you will find limitations, but those limitations could be beyond the scope of what you're expected to deliver. So it's very important to understand what it is that you're trying to achieve. As far as the last 2 points in defects, this is not only defects in the application itself, but also anything related to tester error. So it's very important that the tests are conducted correctly so that if something is found, that's immediately accepted as a credible outcome. And until you have that credibility, that in itself can be a source of waiting, of back and forth interactions that doesn't contribute to value. So it's very important to control that element. And resource misuse. First of all, this is if you have a various team of, you can have ranging from novice engineers or novice testers to very sophisticated and highly technically proficient team members who are in fact have design capabilities themselves. So you want to have the best resources dealing with the most complex and critical items. This is even more the case when you have a limited pool who are actually eligible to test something. For example, if it's security cleared, only those with that clearance can test the restricted parts. So while you have restricted parts prioritized, you can't have their time consumed with less important activities. So all of these wastes are issues that have to be managed, and it's important that by doing so, waste will be reduced, the value of what they're doing can more easily be tracked, and constant changes can be made so that you get the optimal outcomes. So the way, I'll just let the screen update, because I know with webinars, sometimes there's a lagging time. So I'm now showing a slide with that segments testing into 6 distinct backlogs. And these backlog activities are interrelated, and they actually, they can support each other. So incrementally from designing the tests, mapping out what has to be tested and the way to do it, all the way through to the point where it's integrated, you have something that's approved for the production environment. So if someone were to ask me, how long does it take to test a product? And it takes me a moment to hesitate. It's not because I'm confused. What I'm actually doing is assessing how much time it would take for these 6 mini projects within the test project. And this is different from, for example, the protocol of practices like you might find in project management or software development, where they'll base the testing on a ratio relative to development. So let's say if it takes 10 weeks to develop, they say, okay, based on that, it'll take 5 weeks to test. And that does not truly tell the story. By breaking it down into distinct backlogs, this gives more transparency on the work that needs to be done, and also to showcase that the more that's done early on in the foundational starting points, the easier that the less time you'll spend on the execution and defect resolution. So in describing the backlog phases, I show 4 different characteristics. So what is needed to begin or continue the phase? Just to refer back, all of the testing is dependent on having the requirements, the design, the code, so the app code or objects or modules or whatever the application or system you're testing, and the environment. And what could also be included is if what you're testing is firmware or something that's dependent on a particular device or a simulator, having that available as well. So there are things that have to be provided to the test team, and that will define when you can start. So once you have this, you've got the dependencies identified. What is done during this as part of fulfilling this backlog and addressing the work, and when this backlog is done, what is the next thing that you are able to do? Because there is a relationship, so you've got to understand that even within the testing, there are internal customers within that group. So, and then how does that support overall testing? So in the first part, what I've broken it down into a sequence of the 6 backlogs, and I'm sharing this, so I won't read off it. I've got a description for each of these, and what's very important to understand is that it's really the testing itself, judging whether the application is acceptable or deficient and needs correction. That starts either at the automation or the execution points, and there are dependencies on having a good test design, good test data to do that. So, and then by doing those, there's a go no go decision after the defects are resolved, and this go no go decision is not just based on completing the test, but also a level of comfort that the users have with the application and the readiness of the application to go into production. So what you're really doing is the testing is not just to fill a checklist, it's to build a base of evidence to support a go decision. So that's why you have to have the coverage to objectively make the case that what you're testing is suitable to be integrated. So the first part, test design, this is the point at which there's definition for a given requirement or design, how it will be verified and validated. And it has to be done based on not just the technology, but the capabilities of the people conducting or performing the testing. Or in the case if it's intended for automation, enough that it can be, you can have a suitably automated application to repeatedly perform this type of test. And just as an example, when I was in Seattle, I asked the question, I don't know the people who are online or those who may be listening in the recorded, but imagine the instruction, take the car out of the garage, back it up down the driveway, and parallel park it on the street in front of the house. So that's a very simple, high level, but if you had to describe that same set of actions on a step-by-step basis, it would end up being about 30 steps. So the first thing you'd have to do is you go into the garage, open the garage door, open the door, sit in the car, close the door, put the key in the ignition, turn the ignition, and you can see that by however granular you make the instructions, that's the level that you have to apply the same level in your testing. So it's the granularity depends on the sophistication of the tester and making sure that you get a consistent outcome relative to expectations. So that's where the test designs, the test cases, it's really like a mini experiment, and the test steps are the step-by-step, what should be done and what do you do next. And at certain points, the more visual you have this, with screen captures, or you can have recorded capture playback robot programs that will help with the test design so that it can then be assigned to the different people on your team, and those people to whom it's assigned can carry it out without having to be directly monitored. It's the more robustly this test design is done, the easier the subsequent phases and backlogs will be managed. Test data is the second one, and this is an extension of the test design, but in some cases, test data itself has to be crafted to fit not just the test case or test steps, but also to understand how the application would be performed in a realistic situation. So this is especially true if you're dealing with, let's say you're dealing with tax preparation software. The test data would represent the different types of tax payment scenarios. So it could be a single income family, a double income family at various income levels, people getting income from work, getting income from investment, getting income from, say, the sale of a property. So all of these examples would have to be defined and created so that the more robust the test data is, then the easier it will be to actually conduct or automate the tests. In the case of automation, this could be the range of scenarios that would be, say, on a comma separated value field that an automated application could then refer to until the list was fully exhausted. And as well, when the test data, if there's more test data needed than the test design originally anticipated, this is a way that you could respond back to the test design phase and pull, kind of the same way that Kanban pulls the inventory. you can use the demand for a revised test design to pull back and draw more effort that way. So it's more dynamic. Test automation, there's no requirement to have automated tests. However, the more that you have, especially where it makes sense, the more that you can reduce not just the duration of the test phase, but also reduce how many full-time employees are consumed by test activities. So the best candidates for test automation are either those, for example, in performance testing, where it's much easier to replicate, use automation to replicate, you know, the scalability than to have manual testers try to do that. Or if there are repeated tests that are, the steps are constant and the outcomes are known, then those are good candidates to be automated. So the first thing is, if you have a new build of the application and you have a regression test or what's called a smoke test to determine if this is suitable for further testing, that smoke test can be automated. It's performed very quickly, and you know within, you know, a few minutes whether or not the build is suitable for testing. If you don't do that smoke test, then you'll spend a lot more time executing, finding defects, writing defect reports on something that's already flawed. So it's better to have something early on that pushes back the test to its developers. And as well, the test, automating the tests, the more robustly it's designed and the more diverse the test data, the easier it will be to determine a robust automation that can be adapted and customized. Now, test automation itself takes effort, so in order to have the payback to justify that effort, there has to be an evaluation of, is it worth the time? Are we automating it, and then are you getting return on the investment spent on that? So that's something that you know, it's got to be determined within the context of the project itself. So if you're finding, for example, that your high-end people are having to be pulled into routine work, that would again makes it a good candidate for automating, so that you can free up your best technical resources. So, and then executing. This is where, once everything is prepared, the execution will run very smoothly and predictably. If you don't have this, if you haven't done the early steps, if you haven't designed the tests in a crisp and detailed manner, then there will be more delays and waiting as people struggle with executing the tests, and it even can require more one-on-one coaching to support some of your more novice testers. So the more robust the test resources are, the easier it will be to execute on the test. And because it's dependent on the application, the environment, something testable, it does not have to wait till every component is available. You can start once you have the materials for your test design and the application or the modules under test, you can conduct that. And these can be assigned you know, to the people as they're available. If you have capacity, if you have more people than there are tests to perform, then you can go back to the earlier phases and have these people, have your team members prepare more test designs, enhance the test data, or expand the test automation. If, on the other hand, there's a higher backlog of tests, then that's where you can you know, ramp up and get people working on the test. So then, if you have more tests than capacity, then it's an easy thing. You just continue on, you know, bring down the throughput so that the work is performed, and either collaboratively so that there's a constant handover. So in such a situation, there should be no waiting time or idle time. So defect resolution. one of two things can happen when a test is conducted. It can be confirmed to work as designed, and then that's reported that you've got, you track that and say this feature meets all of our requirements, and then you don't have to devote further time testing it, or it falls short. There's deficiency in the functionality, or it's not usable, or it creates even inadvertent failures, or for example, something may work, but if you have a particular type of data, good ways are if you have names with special characters in them, like an apostrophe or a hyphen or an accent, and that causes the database to malfunction, then those defects have to be resolved. Now, it was pointed out when I did this in Seattle that the arrows are always pointing forward, but in the case of a defect, it has to cycle back. And depending on the scope of the defect, it might be seen as a minor issue, which just needs a new service release and a retest, or it might need a complete requirement change, which takes you all the way back to redesigning and reformulating the test data. So with defects, it's very important that the testing group presents their information in a credible and objective manner, and has done their part so that, because the first point of resistance from development is that you're doing it wrong. You've done something incorrectly. The product works, and so it's very important to be able to replicate consistently the defect. Now, not all defects work like that. Sometimes they're intermittent. They don't always break every time you do it. It might be only 25% of the time. So whatever outcomes, that those symptoms have to be captured, and the sequence of events leading to those. So then it comes back also to the validity of the test execution, or the suitability if it is found in automation, the suitability of the automation product. So it comes down to what's the cause, and the cleaner and more explicit the tests were to get to that resolution, the easier it'll be to investigate and determine the cause. If the test was done randomly without documentation, without clear reference to the requirement, then that defect will be harder to diagnose, and you will actually have to repeat the prior steps of test design, test data, automation, and execution. So what ends up happening is you have distinct backlogs of executing the planned tests and executing the defect resolutions. So that actually competes with your time, and that's eventually at the end of the project, the defect resolutions take on a higher percentage of the time up to completion. So the final phase, and this is after you have the go, no go. This is making sure that what you have is suitable to be deployed in a live environment. And there are a number of horror stories of software that wasn't suitable. You find this particularly in airlines. If they have a software upgrade and all of a sudden their passenger check-in or their baggage tracking system malfunctions and people can't get on their planes, and then it has cascading problems. So integration is extremely important. That, as mentioned before, all of the prior phases lead up to a successful integration. And in doing that, we also have to have, if there are any gaps identified, those gaps will demand additional test designs and test data to address those specific gaps, and those designs have to be executed, and if there are still defects present, then those have to be resolved as well. So the target is, as the target is a successful integration, everything previous to that has to constructively aggregate to line up to this successful outcome. So as far as project management, now that I've segmented the testing project into six distinct sub-projects. How does this manage? And if we look back to the traditional waterfall, it the starting point is wait until one phase is completed before starting the next, the finish to start dependency. This is something we want to move away from, because doing a finish to start leaves a lot of idle time, and the idle time and waiting time expands the duration of the project. It also misses opportunities where people could be doing something constructive to actually improve the execution of the tests. The alternative is a start to start, so that as soon as you get something, one of the dependencies that enables you to conduct that phase, you can start on that. So if a requirement is available, even before the design or the code or the environment, having the requirement enables the start of test design and test data creation. And once the application is available to test, then it can either be done. The test design can be created to executing the test or automating the test, or both. So if the planned designs are completed and people have excess, they are idle, they can always do more test designs. They can elaborate on different expanded test data. There's no limit to how it can be done, as long as there's value that's there to be gained. So the start to start sets off triggers that are more dynamic than waiting for closure of the prior phase. And finally, the third time, go, no go, everything has to be finished before you can get that magic green light, that magic go decision. So aggregating the multiple, and primarily the two critical ones are the test execution and the defect resolution. You cannot put something in that has still components untested, and you cannot put something in that has outstanding critical or high defects. So having those concurrently managed is critical to not only track but also have estimates, because in any leadership of a test group, there's always the question, how much longer will this take? When will you be done? When can we release this? And by knowing how long those sub-components, those sub-projects take, and what the estimates are, you can give a more objective answer. Because the worst thing is trying to use your intuition or having an arbitrary target that gets missed and subsequently has to slip. That diminishes credibility. It's much better to make that answer with clear estimates based on outstanding task levels, the productivity of your teams, and their expected throughput. So by changing the dependencies, the last point, removing waiting time and idle time from the critical path, that will compress the critical path and give you a better chance of meeting the deadline with what you have. So in order to do this, I'll just give a minute for the screen to refresh. So it's very important that the team doing this consists of versatile resources. Ideally, they should be able to support the project in any of those phases, that they can design tests, they can create test data, they can automate those. That doesn't just happen. It needs cross-training. It needs subject experts working with all of the participants, either through one-on-one coaching or peer testing, or having knowledge transfer and job aids, on a test-by-test basis, so that if people can follow clear step-by-step instructions or have an understanding of how that particular feature is supposed to work, they will become better advocates of quality for that application, and the verification and validation will be more valid. And it's also the indicators of, what assignments can they do, what are they capable of doing, and matching the resource to the work. And it's if it's a mismatch and that it's too easy, you're not challenging the person. They might get discouraged and look, you might lose them because they might want to do something more aligned with what they want to do. But more importantly, if you have something that the person's not qualified or capable of doing, and you'll notice they won't be able to do it, or they'll struggle, and in their struggles it has to have some sort of intervention anyway. So it's better to support them as much as possible, but don't throw them underwater so that they get, they harm the project as well. So it's having the references, artifacts, and test methods helps the team as a whole, and it also holds people accountable. If they're not following the proper test steps or the test references, then you have an individual performance issue that can be resolved. So it gives you that transparency as well. So with this, to summarize, before I take questions, I'll just reinforce, in a software testing projects, there are a number of wastes that could potentially expand the duration. So it's important to understand where's the value, what are the value streams, and then how is this managed with the owners and assignments. And then by knowing what the value streams are as represented by the backlogs, how do we compress the schedule so that we're doing productive work on the backlogs at the right time. And we're using those backlogs to not just drive work forward, but also signal when more work needs to be done. And then how do we adapt and respond to unexpected changes? And really that comes down to when new things come, we have a process to absorb those changes and make sure they're integrated into the test effort. And again, some of that is only capable when you have constant visibility of work being done across all levels of the test project. And ideally, if you have a single tool of record, then changes in one element can be automatically propagated to all team members and all phases. So it's, and most importantly, starting the work on demand once you've met the sufficient dependencies and have the artifacts to conduct it. If you do it before you have those fulfilled, then it can be counterproductive. But at the same time, if you don't have those artifacts, that's a signal that, okay, I'm able to execute a test, but we don't have a test plan for it. So that's a signal to create those test designs, test cases, and test steps. Or another signal is that we're spending too much time on this particular feature. That could be a signal to create a test automation solution as a way to get the same result but with shorter time and fewer people. So it's very important to always monitor and look for opportunities to optimize. So at this point, I'll open it up for questions, and I can cycle back to parts of the presentation that will elaborate on the response.
Hi, Dan. Great job. This is Kurt. We've had no questions forwarded through the chat room. I do have all phones unmuted, so if someone is muted, they need to do a mouse over on the microphone and unclick it so that it's no longer red. But if you'd like to ask some questions, this would be the time.
Well, sometimes the questions may not be immediately available, but if you do come up with anything, after reviewing this, I've got my contact email as well, and I'd be happy to connect either on this, or I'm also on LinkedIn or MyASQ, and would be happy to respond to any of not just questions, but for example, in Seattle, some people wanted me to elaborate on some of the things that I discussed. I'd be delighted to do that as well.
I see that Kay E has a question, but she's not connected, or he's not connected to audio. Just out of curiosity, Dan, could you go to the top of your bar, your menu, and do you have a communication tab way up top above the screen? If you do you know, your red menu that drops down, if you click on that, do you see a communication option?
No, it just, well, it says chat. I can open up the chat. Yes, I'm on the chat.
Hi, Dan. Can you hear me?
Yes.
Yes.
Okay, great. Yeah, I just typed a couple of items here. So thank you. First of all, thank you for the excellent presentation. And the dynamic test planning that you're referencing is looks like it's the same as agile test planning, correct? Or are there any differences that between agile test planning and dynamic test planning?
No, it's and it's I'll go to the phase here because agile is it's a distinct methodology, and I've worked in agile, and I'll probably do a presentation, a separate presentation on that. What agile is that you actually have at the start, everything is combined. You have the user stories. You can actually, in some instances, you write the test before as what's called test-driven development. So the test case is actually one of the requirements of development, and then everyone convenes in, you know, whatever increment, whether it's 15-day or 30-day sprints, and comes out of that with all of their particular items. So this is not agile in the sense that it's meant to be cycled repeatedly. This is very much adapted from a traditional waterfall, which would be an end-to-end thing. But that said, there are multiple iterations of this, so that as tests are executed, if the need arises to create more test designs or expand the test data automation, that you have that capability to respond back to that.
Okay, and the second question is, what type of tools do you use and recommend to support this concept of dynamic test planning, where you have the requirements, test cases, and everything at one place, instead of having, I think you mentioned about having in multiple tools that is actually based on the base. So what type of tools do you have used that improve the efficiency and supports the end-to-end traceability and reduces waste?
That is a good question. A lot of the big producers have suites, to do that. I've had direct exposure recently to the Rational suite and HP suite, which and the benefit of that also ServiceNow, but more of a DevOps thing. But they've got different modules as well. But you know, anything that will take something at the requirements phase, and then you can carry it through all the way to not just the end of testing, but also if it can be used for post-release maintenance, so incident and problem management, that is very good. I think now the problem with recommending, when I've used those tools, they've been as part of large organizations with extensive budgets, and I think there are some other options at a lower price, or even freeware, that can also be used. So and then to supplement that, SharePoint, if the organization has a SharePoint set up within or equivalent internal intranet, those are very useful for tracking and sending the notifications, so that everyone is informed, and as long as everyone's following the same system, that should be helpful.
Okay, thank you. And also, do you recommend any specific courses or anything for test case writing, where most of the organizations struggle with not just getting these right tools in place, also understanding the concepts of testing, where how do you write a good test case, and how do you trace it back to good requirements, right? Those are kind of challenges. So do you have any recommendation on how do you go about developing a courseware for test case writing and introducing the concepts to?
I've actually taught this as well, and the references I used were the absolute top name is Kem Kaner, and he's got multiple books. James Bach, Hung Nguyen. It depends. For example, if it's there are a number of publications with web testing that Hung Nguyen worked at, and so the books Lessons Learned in Software Testing, Testing Computer Software. Also Steve McConnell, who is actually based in the Pacific Northwest. He wrote his most famous book is Code Complete, but he's got a number of books on software quality, software testing. ASQ has the CSQE handbook, which also gives some very good insights on that, and it draws from IEEE standards. So let's see, the 829 is test planning. I think 828. I've got the standard right here. Hang on. So the let's see, 830 is requirements. So IEEE 830 is requirements specifications, and 829 is test documentation. So.
Okay, thank you.
Thank you.
So if anyone has a question, they could put it in the chat window, not the Q&A, the chat window. And we'll just read it from there. Duke had asked, will a certificate of participation be sent out? Yes. So participation will be rewarded with 0.1 RUs.
Those of you who are collecting RUs, this is a good. These webinars are good. I have two recommendations. First, that means you're recertifying. So if you renew your ASQ certification 32 days or more in advance, you will get a promotion code which will enable you to save $69 on your upcoming renewal fees. And the recertification, these are good, but also if you present or create content, that's very rewarded by ASQ as well. So I encourage you, if you want to do this, to approach divisions, sections, member units, or even ASQ conferences and actively get involved as a presenter or a viewer, an author. There are many ways to get your certification renewed. Then that's primarily I got my first certifications 20 years ago, and that's helped me as doing these as articles and presentations. So I highly recommend your involvement with this.
All right. And as Dan had said earlier, if you have questions, and for whatever reason we're not getting to your question now, you'll have Dan's contact information. He's on LinkedIn, so you can reach Dan. You can get a hold of him to ask your questions. This was recorded, so there will be a recording available. And I think that's it, that we have reached the end of the program. I'd like to thank everyone for their participation, and bear with us as we're moving from one platform to another. I apologize. And as you can see, Dan has put his email in the chat room for all to see. All right, and with that, I'd like to say thank you very much, and good day.
Thank you.
Thank you.